Hello, let's continue our Sudoku adventure with 2.qg4 by Frappy. So we have normal Sudoku rules in every row, every column, and every 2x3 box. We are placing the digits 1 to 6 exactly once each. We also have arrows in the grid. So there's circles with attached lines that are called arrows. And so the digits on the arrow sum to the value in the circle. So let's give a really simple example. If this was 1 and 3, those sum to 4, you put a 4 in the circle. All right. Additionally, we have anti-queen, but only on the even digits. So if we have an even digit somewhere, like a 2, then normal Sudoku rules say that none of these digits can be a 2. I'm going to make those green here. So the 2 is purple. What can't be 2 is green. With anti-queen, you also look at the diagonals that 2 is on, and you also can't put another 2 on that diagonal. So this 2 here would prevent 2 from being in any of those green cells. All right, so and that's how a queen moves in chess. Queen can move in any of these ways. So you could also call it a bishop move if you wanted, because normal Sudoku rules already handle the rest of the queen stuff. But why call it bishop when you can call it queen? All right, so those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, so the first thing I see is a few 3-cell arrows where the digits can't repeat because they're in the same box. So this has to be 1 plus 2 plus 3, adding to 6, because that's the highest number we get in this puzzle. Same thing here. This is 1, 2, 3, adding to 6. This one could repeat digits, but we have these two 6s here. So with the anti-queen, I'm sure there's quite a restriction. So this 6 sees these two. This 6 sees down here. We're never putting a 6 on an arrow. So this is going to be a 6. Now this box needs a 6. It's not here, and it's not here because of this diagonal. So this ends up being a 6. I bet we can place the rest of them. Yeah, there's a 6 here, and up here there's a 6 there. Nice. Okay, 6s are done. So these could... Oh, actually, no, sorry. We can't repeat a digit between these two because they're sharing a diagonal. However... and I just noticed on this diagonal here, that's really interesting. This diagonal here seems to have a 1, 2, 3 triple. We can't repeat any digit. Oh, sorry, it's only the evens that can't repeat. Okay, sorry. That is not true. Only the evens can't repeat, so we need to be careful. So we could repeat the 1s here. So we could do like 1 plus 1 plus 4, for example. Okay, yeah, definitely need to remember that. This is a 4-5 pair. So this is either going to be 1-5 or 2-4. I'm not sure how to distinguish that yet. Okay, these two digits add to 6, which is kind of interesting because these two decidedly don't add to 6. They add to at most 5. So, but these two digits need to go up here somewhere. So one of these digits is going to go exactly here. So we don't know which one it is, but one of the 1, 2, 4, 5s is going to go up here. And then the other is going to go on this sum. It's probably something simple I'm missing about all this. This is a 4-5 pair as well. So this is from 1, 2, 3. So we have a 1, 2, 3 triple here. So this is a 4-5 pair. Okay, so 5 is too big, right? Because the minimum of these two is 2. 2 plus 5 is 7. So this is the 4. This is the 5. This is not a 4. 4 is definitely not repeating on this arrow because that would make it sum to 8 already. In fact, these are both 1s because 1 plus 1 plus 4 is 6. So they have to be the minimums. So let's clear out all these 1s. This is going to be a 2-4 pair. So this is going to be the 2 from that 2-4 pair. And then this is going to be a 3-5 pair. And that also goes down here. And clear up that 2 there. Okay, so we have this 4 here, yes. So this 4, we can do our queen's move. And 4 is even. So this can't be 4, that's a 5. This is a 4. Now we can bounce up to here, make that a 2. So that is not a 2. And also this is not a 2. So the 2 goes here. Basically it's scanning at this point. Let's see, this 2 sees here, so that's not a 2. Okay, so this is a 3 or a 5. let's just fill what the rest of these can be. So we need 1, 3, 1, 2, and 3 here. The 2 is definitely here. Now, do we have any 2s kind of diagonally looking in? We don't actually seem to. All right, and then here, I don't know about here. It's 4 digits, but I'm going to fill it anyway, because we don't know about the anti-queens. So we need 1, 3, and 5, and then also a 4, which I filled in a strange order, but there we go. So the 4 is up here as well. Now, do we have any 4s looking in? We don't actually seem to. Okay. Well, this 4 actually does need to go in this row somewhere, and the diagonal keeps it from being here. So this does end up 4. That's 5, and that's 4. That makes that a 4. Very nice. Okay. This is 3 and 5. 1, 3. There we go. The rest of this is finishing. Nice. Well, that was a neat introduction to the anti-queen constraint. The reason you don't see it on every digit is because you can't actually create a puzzle with every digit, as far as I know. I know in 9x9, 7 is the maximum, but it's very hard to get 7 squeezed in. 7 individual digits that are anti-queen. I'm not sure about 6x6, actually. I haven't done that. But it's interesting that we ended up with 4 1s all on the main diagonal here. In fact, this ended up all odd on this main diagonal. So I wonder if some of that's forced. In fact, both main diagonals ended up odd only. So I do wonder if something along those lines ends up forced a bit. But yeah, very cool. Thanks, Frappy. And of course, if you enjoyed this, then why not leave a like, subscribe, and a kind comment below.